Hello everyone. Today we are going to study refraction through a prism. Okay. So first, before that, we have to understand what is a prism. Okay. Now, from the definition we know what is a prism. A prism is a portion of transparent medium bounded by two plane faces inclined to each other at a suitable angle. Okay. Now, as you can see from the diagram, now it is given here that it is a portion of transparent medium. So, first thing is it is a transparent medium. Okay. So, it is a transparent medium, first thing. Second thing, it is bounded by two plane surfaces, okay, two plane faces. So, you can see these are two faces PQBA and PRCA. These are two faces which are inclined at an suitable angle, okay, which are inclined at an suitable angle. So, this type of thing is called as prism. Okay. Here A is called as the angle of prism. Okay. Here A is the angle of prism. Now, in this line AP is called as refracting edge of the prism, clear, and section ABC, this section ABC is called as the principal section of the prism. So, this is just the basic of the prism, and today we are going to study about refraction through prism. Okay. Now, we will get into the derivation of this refraction through prism. Okay. So, next in this, first we are going to draw the diagram, okay, for refraction through prism. Now, for say a ray is coming like this is the prism, okay, the angle of the prism is given A, clear. Now, for say a ray is coming like this, okay. Now, we will draw a normal to this surface, like this, okay. Now, the ray is going from rarer to denser medium. So, this ray will bend towards the normal. So, it will go like this, okay. Now, for say this angle is R1, this angle we are taking as R1, okay, clear, and this angle we are taking as I, okay. So, this is the for say incident ray, this is the incident ray, which is incident on this prism at an angle I. This is the normal N1 to the surface AB, okay, to the surface AB. Now, after refraction, the angle of refraction is R1 and the ray is going in this way, clear. Now, what will happen at this surface AC? Now, again we will draw a normal to this point, okay, again we will draw a normal to this point for say like this, okay, this is for say N2, clear. Now, what will happen with this ray? Now, in case of rarer to denser, it is moving towards the normal, but what will happen in the case of denser to rarer? It will move away from the normal. So, the ray will go like this, clear. So, this ray is called as emergent ray, okay. This ray is called as emergent ray. So, this is the incident ray, this is the refracted ray and this is the emergent ray, okay. Now, let us say we are taking this second angle as R2, okay, this second angle as R2 and this as L, this point and this point as M and this point as O, clear. Now, look, if the prism is not there, what will happen? If the prism will not be there, what will happen? This ray will go like this, okay. So, the original path of the ray is like this, but because of the prism it suffers two refraction and went like this, okay. So, this is the original path of the ray before refraction and this is the path of the ray after refraction. So, if we extend this ray like this and extend this emergent ray like this, so we will get what here? We will get here the deviation. This angle is called as angle of deviation, means because of the prism the incident ray deviated through this angle delta, okay. Now, we will get the value of this delta, okay. Now, let us see in triangle PLM, okay. What will happen in this triangle PLM? Okay. Now look, this angle is I. So because of this angle PLO is also going to be I, because opposite angle, these are opposite angle, so these are going to be equal. Okay. So first we can write delta. So first delta is going to be what? First in triangle PLM, what is going to be the delta? Now we know that sum of an exterior angle is equals to the sum of two interior angles. So in this case delta will be equals to angle PLM plus angle PML. Okay, PLM plus PML. Now what is going to be the angle PLM? So this is I. So this total is also I. So angle PLM is going to be I minus R1. Okay. So angle PLM will become I minus R1. Why this angle is also I? Opposite angle. These two angles are opposite angles. So therefore this is also I. So therefore it will be also I. So this angle PLM will be I minus R1. In the same way, PML will become E minus, for say this angle is E. So angle PML will become E minus R2. Clear? Now solving this further, we will get I plus E, okay, minus R1 plus R2. This is equation 1. Clear? This is equation 1. I plus E minus R1 plus R2. So this is the equation 1. Okay. Now we will take next triangle, triangle OLM. So what will happen in triangle OLM? In triangle OLM, what will happen? Now look, we know that sum of all the angles of a triangle is 180. So from there we can write angle R1 plus angle R2 plus angle O equals to 180. Clear? Angle R1 plus angle R2 plus this angle O. This angle O is equals to 180. Okay. This is equation 2. Clear? Now this N1 is perpendicular to this surface and this N2 is perpendicular to this surface. So what is going to be this angle then? ALO. If this is the normal, then angle ALO is going to be 90 degree, and in the same way angle AMO is also going to be 90 degree. So we can write that angle L plus angle M is equals to 90 degree. We can write that in this quadrilateral, for say, or like this only, we can write angle A plus angle angle L, angle L this one, okay, plus angle M this one is equals to 180. So angle L, this angle M, this angle is 180. Now we know that the sum of all the angles of a quadrilateral is 180. So from there we can write, if this is 180, this and this is 180, then what will happen? These two angle A plus angle O will become 360 minus 180. So 180. So we can write from there that angle A plus angle O equals to 180. Okay. So angle A plus angle O equals to 180. Now we see that angle R1 plus R2 plus O is also 180 and angle A plus angle O is also 180. Okay. Now we will equate these two equations. We will equate these two equations. So if we equate these two equations, this one and this one, what will happen? We can write that angle R1 plus angle R2 plus angle O is equals to, now this, look, this is R1, this is R2 plus angle O is 180, and also this angle A plus angle O is 180. So what we can write from here? We can write this angle is equals, this is equals to this one. So angle A plus angle O. Clear? Now in this what will happen? This O and O will cancel out from both the side. So we will get angle R1 plus angle R2 equals to angle A. So this is the relation for the two 2 angle R1 plus angle R2 is equals to the angle of the prism. Okay. So, this is clear. Now, we know that delta is equals to I plus E minus A, I plus E, okay, minus R1 plus R2, R1 plus R2. Okay. So, what will happen then? Next step, what could be the next step here for say, if this is equal to this one, what will be the next step? So, the next step will become in place of R1 and R2 we will put A. So, it will become I plus E minus A, clear. So, the value of delta is I plus E minus A, clear. So, this is the delta for I plus E minus A. This is also the equation of delta. Okay. Now, in this next we will see for say if mu is the refractive index of this medium, okay, then what will happen? Let us see. If mu is the refractive index of this medium, now look, if mu is the refractive index of this medium, so from Snell's law we can write, from Snell's law, okay, from Snell's law we can write, now look here for this surface, if you will see, this is the angle of incidence I, this is the angle of refraction I. So, we will apply Snell's law here. So, we know that Snell's law is the what? Snell's law is refractive index of this medium, that is 1, refractive index of air into sine of angle of incidence, that is I, equals to refractive index of this medium, that is mu, into sine of angle of refraction of this medium R1, clear. We can write this. Now, we know that for small value of theta, for say if sin theta is very small, then we can write in place of sin theta we can write theta, we know that. So, therefore, we can write here as a I equals to mu R1, we can write, okay, for this surface I equals to mu R1. In the same way, if we apply Snell's law in this surface AC, then what will happen? We can write the equation that mu into sine R2 is equals to 1 into sine E, we can write in this way. So, from here also we can write that E equals to mu R2, okay. So, we get the value I equals to mu R1, E equals to mu R2, okay. Now, what we will do? We will put the value now we will put the value of this in the equation I plus E minus A, okay. This is the equation we have got earlier. So, we will put the value here, what we will get? We will get in place of I we will write mu R1, in place of E we will write mu R2, okay, minus A, clear. So, what will happen then? So, it will become mu, okay, R1 plus R2 minus A, clear. If you solve this further here, if you solve this further, okay. Now, what will happen here? If we solve this further, we can write that delta equals to mu R1 plus R2. Now we have seen earlier that R1 plus R2, the value of R1 plus R2 is equals to A. We have seen earlier the value of R1 plus R2 is equals to A. So, we will put the value here, we will get mu A minus A. Okay. So, we can write mu minus 1 into A, this is delta. So, the other equation for deviation is mu minus 1 into A, clear. This is the other equation of delta. Okay. Now, this is the other equation. Now, we will do what? We will see one case, the case of minimum deviation. Okay. In this, we will see one case of minimum deviation. Now, what will happen in case of minimum deviation? What will happen in the case of minimum deviation? Now, we know that in case of minimum deviation, what happens? The angle of incidence become equals to angle of emergent. Okay? Angle of incidence become equals to, this is the first condition for minimum deviation. We are talking about minimum deviation. Okay. So, what will happen in this case? Angle I becomes equal to angle E, means angle of incidence is equals to angle of emergent, and what will happen in the case, second case, that R1 become equals to R2 become equals to R, clear. So, these are the two cases of minimum deviation. So, what will happen with the value of A for say? Now, we know the equation that R1 plus R2 is equals to A, clear. R1 plus R2 is equals to A. So, if R1 is equal to R2 equals to R, then what will happen? It will become R1 plus, sorry, R plus R equals to A. So, it will become 2R equals to A. So, therefore, from here we can write R equals to A by 2, clear? This is clear? Now, next what will happen? I is equals to E. Okay. So, next what will happen with the angle of incidence? Now, we know that I is equals to, or delta is equals to I plus E minus A, we know that. Okay. So, here in this place, because of minimum deviation, we will write here delta M, okay, delta minimum. Now, what will happen? Now, this I is equals to E. So, in place of E, we can write I. So, I plus I, it will become 2I. So, we can write 2I minus A equals to delta M, okay, or then what will be the I in case then? I will become, now this will go this side, so it will become delta M plus A by 2, this will be the value of I. So, in case of minimum deviation, we can see that angle of refraction is becoming A by 2 and angle of incidence is becoming delta M by 2. So, what will happen with mu? Okay. Now, we will find out the mu for this one. Okay. Mu for this one. So, what will happen? Now, we know that mu is equals to sine of I by sine of R, clear. So, in this case, I is equals to delta M plus A by 2. So, we can write sine of delta M plus A by 2, okay, by sine of, now R is A by 2, so A by 2, okay, sine of A by 2. So, this is known as this is known as, this formula is known as Prism formula. Okay. This formula is known as Prism formula. Mu equals to sine of delta m plus a by 2 by sine of a by 2. Okay. This is known as Prism formula. Clear? So this is the end of this topic. Okay. Refraction through a prism. Okay. Thank you.